We exist in a world shaped by powers beyond our control, a planet where raw elemental forces relentlessly rewrite the laws of existence. The landscapes we inhabit are monuments to ancient violence and endless rebirth, where every mountain and valley tells a tale of unimaginable energy. This is Prime Earth. A formidable and deadly force resides in the narrow body of water separating the islands of Java and Sumatra. In this region, where the Earth's crust is inherently fragile, intense subterranean pressures have repeatedly manifested in catastrophic eruptions, leaving a legacy of death and widespread devastation. Approximately 150 years ago, a blast occurred here with such extreme violence that it may hold the historical record for the loudest sound ever recorded by human ears. This notorious volcano is known as Krakatoa. Indonesia is a vast island chain comprising several major well-known landmasses alongside thousands of smaller islands. Its location on the convergence point of two tectonic plates makes it a pivotal part of the Pacific Ring of Fire. Consequently, the nation hosts over 130 active volcanoes, a greater number than any other country globally. The majority of these are situated on the large islands of Sumatra and Java, lying directly above a subduction zone, where the Australian plate is forced underneath the Sunda plate. This process of plate subduction is the principal cause of most of the world's volcanism. As the buried plate descends, trapped water lowers the melting point of the rock, causing it to liquefy into magma, which then rises to the surface and erupts through volcanic cones. It is within the Sunda Strait, situated between these two prominent islands, that the lethal Krakatoa is found. Given the intense geological history of the area, the current form of Krakatoa is merely a fleeting snapshot of an ever-evolving landscape. The site is fundamentally dominated by a huge stratovolcano, a steep-sided cone built up from numerous layers of hardened lava, ash, and rock debris. Today, the remnants of this giant are scattered across 4 separate islands, collectively defining a massive caldera. A caldera is a large depression formed when the underlying magma chamber is emptied by an eruption, causing the unsupported rock above to collapse inward, though the outer rim often remains intact. The name Krakatoa itself is one of many historical names, with varied spellings resulting from the different languages of the European colonial powers interacting with the local dialect. While Krakatau is now the officially accepted form, I will continue to use the more widely recognized name Krakatoa. This volcanic region has a long history of regular explosions, with accounts dating back as far as 416 AD. These eruptions continued roughly every century until European powers arrived in the 1600s, leading to more meticulous records. In 1681, Dutch travelers recorded significant destruction on the island while sailing through the Sunda Strait. By 1780, a British Royal Navy crew reported finding both human settlement and flourishing vegetation there. However, another century later, the stage was set for the catastrophic 1883 event, an explosion that cemented Krakatoa's reputation as a geographical horror, rivaled perhaps only by Vesuvius. In the years leading up to 1883, the area experienced a marked increase in seismic activity. By May of that year, one of the volcano's three peaks began steadily vented steam and ash, covering the surrounding area. Earthquakes became commonplace, felt even in Batavia, modern-day Jakarta, 160 kilometers away. The intensity escalated dramatically on August 25th. By the afternoon of the 26th, a colossal column of black ash had shot up to 27 kilometers high, with loud blasts occurring every few minutes. Ships passing through the strait were bombarded by pumice stones as large as 10 centimeters. That evening, a minor tsunami struck the nearby coasts. The morning of August 27th, however, marked Krakatoa's most infamous moment, featuring 4 immense eruptions timed precisely at 5:30 a.m., 6:44 a.m., 10:02 a.m., and 10:41 a.m. Although each blast had devastating local effects, it was the sheer force and suddenness of the explosions that generated atmospheric pressure waves of a magnitude that entered the history books. The third of these explosions is widely considered to be the loudest sound ever heard in recorded history. It was audible across 10% of the Earth's surface, heard over 3,110 kilometers away, in Perth, Western Australia, and even 4,800 kilometers away on Rodriguez Island, near Mauritius, where sailors mistook the tremendous noise for nearby cannon fire. The accompanying atmospheric pressure wave was registered on instruments across the globe, reaching as far as Europe and the United States. In Batavia, 160 kilometers away, the sound intensity was calculated to be 180 decibels. Comparable to standing next to a launching rocket. Sailors 64 kilometers away in the Sunda Strait would have had their eardrums burst, and anyone within 16 kilometers would have been instantly and permanently deafened. At the very epicenter, the sound was an almost incomprehensible 310 decibels. Considering the decibel scale is logarithmic, where 100 decibels is already considered loud, the energy at the source was calculated to be 100 billion times greater than a running chainsaw. The immense power is underscored by the estimate that the explosion released energy equivalent to 200 megatons of TNT, 4 times the force of the Soviet Tsar Bomba, the largest thermonuclear device ever detonated. The day's blasts ejected approximately 25 cubic kilometers of material and utterly destroyed the mountain. The heaviest components of the superheated plume, which had reached 80 kilometers into the sky, collapsed and rushed down as a lethal pyroclastic flow of hot ash, rock, and gas. This flow traveled 64 kilometers to the village of Ketimbang, killing hundreds. Sebesi Island, which was much closer, was entirely consumed and its 3,000 residents perished without a single survivor. More significantly, the enormous force of this pyroclastic material hitting the ocean displaced several cubic kilometers of water, triggering a massive series of tsunamis. The wave that devastated the town of Merak, 70 kilometers away, was estimated to be at least 40 meters high. This tsunami was the primary cause of the appalling loss of life. The official Dutch death toll for the entire disaster was 36,417, with an estimated 34,000 of these fatalities attributed directly to the waves. Although some estimates push the total casualty count as high as 120,000, the official figure still ranks the Krakatoa eruption as the second deadliest in recorded history. The eruption's effects were not merely regional. The vast amount of ash and sulfur dioxide injected into the atmosphere caused global temperatures to drop by up to 0.4 degrees Celsius the following year, and produced the striking sunsets that were widely recorded by artists across Europe and America. Despite its apocalyptic renown, Krakatoa's 1883 eruption is less severe than other historical events in the geological record. Since the 1980s, volcanologists have used the Volcanic Explosivity Index, VEI, to quantify the severity of eruptions. Like the Richter scale for earthquakes, the VEI is logarithmic. A VEI 7 is 10 times more powerful than a VEI 6 and 100 times more than a VEI 5. This severity is based on multiple measurable factors, primarily the total volume of ejected material and the height of the eruption column. Because this data often relies on historical estimation, the VEI is subjective and best used for quick comparison. The 1883 Krakatoa eruption registers as a 6, or colossal, placing it on the same scale as Mount Pinatubo, 1991, but an order of magnitude more severe than Mount St. Helens, VEI 5, 1980, or Vesuvius, VEI 5, 79 AD. Krakatoa, however, is not the largest recorded blast. Earlier in that same century, another volcano just a few hundred miles to the east, Mount Tambora, exploded with a VEI of 7, an order of magnitude more powerful. Its supercolossal 1815 eruption ejected 40 cubic kilometers of rock, making it the largest recorded blast in history and likely the largest in the last 10,000 years. Tambora's eruption killed 70,000 to 100,000 people, directly and drastically altered the world's climate in the following years. This alteration caused the year without a summer in 1816 Europe, which led to widespread famine, disease, and potentially hundreds of thousands of additional deaths. Further west of Krakatoa, evidence exists for an even more immense catastrophe, the VEI 8 megacolossal Toba eruption approximately 74,000 years ago. This blast was so devastating that it is hypothesized to have nearly extinguished the human race, with genetic studies of mitochondrial DNA showing evidence of a population bottleneck at that time. The Indonesian archipelago is undeniably a hotspot for the most famous volcanic tragedies in recent history. Yet, alongside the devastation, this seismic activity has a profound positive impact. It is no accident that Java, a relatively small island, 1,000 kilometers east-west by 150 kilometers north-south, supports an incredible population of 147 million people. The soil on Java, rich in mineral-laden ash from countless volcanoes, has acted as a natural, potent fertilizer for thousands of years. Thus, while these volcanoes occasionally cause immense human tragedy, they are also fundamental to sustaining life. To return to Krakatoa, the story did not end in 1883. Although the original island was shattered and the empty magma chamber resulted in the collapsed caldera and 4 new islands, a new volcanic cone has since emerged at the center. Known as Anak Krakatoa, or Child of Krakatoa, this island grew to 338 meters in height after its first appearance in 1927, until its 2018 eruption caused a massive collapse of its cone. This collapse triggered a tsunami that killed 437 people and injured thousands more. Even now, at the time of this writing, another eruption is underway on the island. The cycle is destined to continue, possibly for millions of years. Anak Krakatoa will regrow, and perhaps 2 or 3 centuries from now, we will witness the next catastrophe in the continuing, evolving story of Krakatoa.